Hello, Mr. Ryan, right? What's this? Square. Oh, yeah, square. What's this in data structure?
Cycle.
Cycle, yeah. So what kind of thing we are talking about when we talk about cycles? What?
Undirected.
Undirected what?
Graph.
Yeah, the graph is the thing I'm looking for here, okay? Graph. Okay, so look, imagine this is the bus stop, right? There are 4 bus stops and then there are cycles, yeah, the bus stop. So look, the distance between 0 and 1, the vertex, yeah, in the graph is 1, and 1 to 2 is 2, 2 to 3, 3 to 4 is 3 to 0. Undirected weighted graph. Undirected weighted graph. Weighted means that
Weighted means
the edges between the vertex that is noted, right? We
Yeah.
have yeah. Okay, so if we given a start and stop, right? For example, like we given a start and here, and a stop and here. We given only 2 vertices here, so we want to find out the shortest distance between them. So what's the shortest distance between vertex 0 and vertex 1? If you look at this graph, yeah. If you're looking at this graph, what's the shortest distance?
1.
Okay, if I put this 8, what's the shortest distance between, maybe no, 18, okay? What's the shortest distance between 0 to and 1 here?
That's impossible.
Why is that?
Because they have the same length, but
Yeah.
they have
Come on.
different length. But
Yeah, I know,
But
but
it-
forget about, but this is weighted.
Yeah, at the bottom it's 3, but at the top is 18. And then at
and
the
3 is a
9.
bit longer.
When we talk about a graph, we're not actually looking at the length. That's why we say weighted. What's the shortest distance between 0 and 1, or 1 to 0?
9.
How do you get that?
Bottom half.
Yeah. So basically, how many choices can we get travel between 2 stops in this particular unweighted
In
weight?
a square.
Yeah, in this square undirected weighted graph. Remember, we
2.
have this 2. Yeah. So we want to find the minimum of it. We are given undirected, right? Both way. Undirected means both way. Weighted graph means the cost between the edges are different, right? If it's unweighted, it means the cost between the edges are all the same. We can think of it as 1 or equal. Yeah. Okay. So if an equivalent can be used on a directed graph, then it can also be used in the undirected graph. Am I right? Yeah. If a equivalent can be used on a weighted graph, then it can also be used on an unweighted graph. This is a simple question. We can just compare the minimum of 2 paths to make sure the first index always comes before the second index. We can compute the distance of this and then the distance of that, and we can get the minimum. Define the shortest distance in the graph, right? In the graph, we given this the distance, and then we have this the start, and we have the stop. So the start may comes after stop in the graph, right? The start maybe comes after the stop. So in the case, we can swap it. So if start is bigger than stop, then we swap it. How do we swap 2 variables, a and b? How do we swap a and b here? A, b equals what?
BA.
Easy, yeah. Only in Python you can do this. But if it's other programming language, we need to use another variable to do it. So for example, t equals a equals b equals t, right? Yeah. We need to make a copy of the value of a, and then before it assign a new value b, right? And then this is to restore the original value of a. So this is the traditional way of exchanging 2 variables using the third variable. If start bigger than stop, then stop equals stop start. Okay, we just exchanging these 2 variables. So after this, so the start is always smaller than stop. Okay, now we want to calculate the distance here. This distance d1 equals sum. We're using the sum, right? Sum distance of start up to stop. This is this bit. And how do we calculate this bit? How do we calculate this bit? Come on. There are 2 ways of doing it. This bit is d1. We just calculate it. d1 equals sum d start to stop. What's the distance of this bit? How do you get that? 2 ways. There are 2 ways of doing it. Adding. Yeah, we can add it, or we can do this subtraction. We know if we know this all together. If we say d0 equals sum of everything d. Right? So this is every cost. Then with d2 will be d0 minus d1. Right? Right? The total cost is 18 plus 2 plus 3 plus 4 minus 18. Then the cost will be the other path. Yeah? The cost, the distance between other paths. So we just return the minimum. Minimum of d1 and then d2 here. This is star and this is stop. Another way would be calculate this bit plus this bit. Okay, so this d2 can also be written as sum of the d up to star plus sum d stop to the end. Right? One way we know this d1. Yeah, d1 is start to stop here. So one way is to do this subtraction. Yeah? The other way is to calculate the distance between the star and the distance after the stop. Because these two rounds up a circle, right? Look at these two rounds up a circle. You see? Yeah? Rounds up a circle. One last question. What's the problem and what have you learned today? Eric?
The shortest path.
Oh, what do we have here? What do we have here? This is bus stop. These are bus stop. And what do we have?
We have a graph.
We have graph. What kind of graph is it?
Undirected.
Undirected weighted graph.
Oh.
And we want to calculate the shortest distance, and there is only two possibilities. Yeah? This is a very simple graph. It's a regular graph. Okay, so let's talk about the concept. The regular graph. Regular graph is that any vertex in the graph has the same number of neighbors. For example, each vertex in the graph has a same number of vertex, right? Same number of neighbors. This is the graph which has a cycle. It's a regular graph. It's a connected graph, right? It's all the neighbors can be visited by any. All the vertex can be visited by any vertex, right? And then it's undirected. It's a weighted graph, and then we only have two possibilities. We just iterate. We just brute force it, right? The time complexity is O n if there are n vertex, right? Because we want to calculate the distance, the sum of the distance between any two stops. Okay, that's it for today. Bye bye. Bye bye.